Hi everybody. In this second video on the series of arrays and pointers, I'll carry on where we left last time. So in the last video we had talked about the differences between declaration and definition, and also discussed about L values and R values in a programming language. So let's take the discussion forward. So let's discuss what is the definition of a pointer and how pointers can be used in a program. So what do I mean when I write int pointer x? So what this means is that x is a pointer variable of type integer. What is a pointer variable of a type integer? What it means is that x stores the address of an integer. So pointers, as you all know, are special kinds of variables which can be used to store the address of other variables. So they can be used for indirectly accessing other variables in the memory. So when we declare something like int star x, what it says is that x contains the address of another integer. So for example, if I have an integer a and it contains the value 3, so in the memory of the system there will be the variable a and it will be at some address, let's say 5800, and a will contain the value 3, and now what this variable x will contain is the address of 5800, and this x is a pointer variable which in itself will be located at some other place in the memory. So that is independent of the value that x can refer to. So in this case, suppose we want to refer to the value 3, what we do is we write star of x. Star of x refers to 3, and to assign the address of a to x, what we do is we write x equals ampersand a. So basically this will copy the address of a to x, and using this we can modify the value of a. So when we make star of x equal to 4, what this will do is this will basically change the value from 3 to 4. So that is the concept of pointers. Now there is one thing in pointers I want to highlight. Essentially, when you have a declaration of the type int star x, and when you write x is ampersand of a, and when you have int a declared elsewhere, so in this case the compiler just reserves space for x only. It doesn't reserve space for a. So a will be reserved space only when a has been defined. So in a normal scenario, a pointer definition, so both of this will combine to be a definition. A pointer definition basically reserves space only for the pointer itself. It doesn't reserve space for the object that the pointer is pointing to. This is an important point, but there is also an exception here. Now if you have a character pointer on the other hand, a character pointer p, and you define it as a string literal, so in this case and only in this case, space is reserved for the string literal as well. Once again, so any pointer definition only reserves space for the pointer itself. It doesn't reserve space for what it is being pointed at. And on the other hand, when you have a pointer defined using a string literal, in this case you have space reserved for the string literal as well. So this is a very special case. For example, as a counter example, actually something like float star t equal to 3.1414, something like this will never work, because a pointer definition will never reserve space for what it is being pointed at. So that is one important thing to note. The next topic, the next point I wanted to cover was that any pointer defined as a string literal, like this we had earlier, this is immutable. What it means is that now you cannot change the value of a, b, c, d, e. For example, you cannot write something like p of 3 equals to e. Something like this won't be allowed, and the compiler will flag an error. So to actually change the value of a string literal, what we have to do is we have to store it in an array. Let's call it a, and let's use the same a, b, c, d, e again. Now to change, let's say, the third character, we can do something like string copy of a, comma, let's change the first three to d, e, f, and let's change 3. So what this will allow us to change this string literal from a, b, c, d, e to d, e, f, d, e. So when you define a string literal as using a pointer, it is immutable and it cannot be changed, and this would be an error. Whereas something of this kind, if you want to change a string literal, you always define it using a character array, and then you can use any of the conventional string copy, or you can use your conventional array access methods to change the value of any particular location. So in the next set of videos, I'll be covering further topics on pointers and arrays. Thanks for watching.